Welcome to class. It's great to have you here. In this lecture, I'm going to walk you through a modest-sized example of using a single class to create some particle objects that we'll use in a simulation. Now, the purpose for this lecture is to get you more experience in working with kind of an object-oriented style of programming. My experience in watching students try to actually implement blackjack is that those that have previous programming experience but no OO experience actually struggle in this project. It's kind of likens it to, I liken this process to learning how to drive on the left-hand side of the road after you've spent your entire life driving on the right-hand side of the road. My wife and I flew into England, and I rented a car, and we drove out of Heathrow Airport. And for the first 30 minutes, as I drove around, my wife's favorite words were, "Oh my God, there's a curb, watch out!" We'd go over the curb. Now, eventually, I figured it out. And for those of you that are struggling, yes, you'll figure it out too. Just be patient. For those that have never programmed before, you actually have a little bit of an advantage here. This won't actually seem strange to you. It'll just be something new that you're learning. What I'm going to do in my example is I'm going to walk through building this little simulator, and I'm going to do it the wrong way. And you'll see where I go wrong. And then I'll do it the right way. And hopefully from that experience of seeing it done both ways, you'll kind of get a little more insight about how you should write OO programs. Okay, let's go to work. Okay, let's take a look at the example that I've built for this lecture. So I've written a fair bit of code here. The example is designed to spawn a collection of particles on the canvas and allow those particles to diffuse across the canvas in the same way that maybe molecules of perfume would diffuse across a room. Kind of the critical thing that I've built here is I built a particle class. The particle class has 4 methods attached to it. There's an initializer. It takes the object itself, the position, and a color. A move method that actually moves the particle. It takes the object itself and an offset. A draw method that takes the object and the canvas. And a string method that takes the object and returns back a string that kind of encodes the data inside the object. Now, one thing to note here is I've used code folding to hide the implementation of these 4 methods. So we're going to build our simulation without understanding or knowing how we've implemented these particular methods. We're going to just trust that they work correctly. And again, I'll do it one of 2 ways. I'll do it kind of an incorrect way where I don't trust what's going on, and I'll do a correct way where I trust it. And then at the end of the lecture, I'll go through and show you how I implemented each of these methods, and we'll talk a little bit about how to kind of use this same approach to finish blackjack. All right, let's work with our code and implement our particle simulator. To do that, I'm going to spawn a list of particles, and then I'm going to actually manipulate them inside the draw handler, make a move and draw them. Now, we've already implemented the particle class, so really this should be pretty easy to do. Let's focus on just first creating some particles. I've got some code written. I have a list that I'm ready to put my particles into, and I want to create 10 of them. So let's do that. Let's make a particle P, and I don't know, how do I build a particle? You know what, let's build a tuple. Maybe that will work. So a tuple, we're going to have to store, I guess, the position and the color. So let's put the particle at the middle of the canvas. That seems like a good idea. And you get a color for it, and I've actually got a list of possible colors up here already called color list. And I remember there's this handy dandy function called random.choice that will actually pick out a random element from a list. So let's use random.choice and apply it to color list. And then I probably need to append that particle to my particle list. I can use the method append. And let's just print out the particle just to check our work real quick before we proceed. Remember, always check things as we go. Looks pretty good, actually. Here we go. We got a position, we've got a color. Built 10 of them. Kind of passes the smell test. Let's go up and do something with them now inside the draw handler. So for each particle P in particle list, what do I need to do? We need to make it move. We need to move it around. Well, you know, right here's this method move. Let's use that method move on my particles and see if we can get that to work. So how do we apply a method to an object? Well, we say object.method, And we have to give it something. And notice here that this object is actually corresponds to the first parameter here inside our move method. So we want to make it move in some offsets. So we can do that. I've already got some code waiting to be used. We can say random.choice of a list of directions that I've already predefined. It's called direction list. So hopefully this will take each of the particles and move it in some random direction. So let's fire that code up real quick. Error. Let's take a close look. Line 39, that's just the line we just typed in. It says attribute error. Tuple object has no attribute move. When you see an attribute error, that means that something went wrong with one of your objects or one of your classes. Here it's telling us that P is a tuple and that we can't use the method move on a tuple. Now that probably makes sense because the method actually move was defined for particles. Let's go do one more thing just to check and make sure this is exactly right. Let's go back down here where we printed out the particle. Let's also print out the type of P. So we thought we created a particle and we printed it out, it looked okay. Let's print out what Python thinks its type is. Well, there's the thing we printed out, but it says class tuple. So it's a tuple. It's not a particle. So we messed up. So give me a second, we'll go back and we'll fix this. Let's clean up our first cut here implementing our particle simulation. The trouble was that we used a tuple to try to represent a particle. Python didn't like that. So what can we do to fix this? Well, all is not lost. What we really need to do is we need to use the method init to create a particle. If we use that method, we'll actually build something that's a particle, and then hopefully the move method will work. So how do we actually call this init method? Well, it's not too difficult. We simply use class name, that's particle, and we give it the parameters position and color. In this particular example, since we actually are creating the particle, self doesn't actually appear. We don't have anything on this side. So notice I said particle, I gave it a position, and I gave it a color. Now let's just try running the code and see what happens. Looking better. So we have, well, where did this come from? This came from the str method. Whenever we said print an object, Python looks for the corresponding str method for that class. When you say print, it calls the str method. And so inside our str method, as we'll see in a few minutes, it actually prints out this data for the particle in a very nice format. Notice that type of the thing says now it's actually a particle. So let's finish it off. Let's see if we can go through and actually complete our particle simulator. So we move the particle. All we need to do now is actually draw the particle. So how do we draw a particle? Well, we got to draw a method. Let's just trust that our draw method works. So we call it by saying object.method. And we need to give it the parameter, which is going to be the canvas. And let's fire it up and see what happens. Hey, looks pretty good. You've got some little circles bouncing around here. They're essentially particles diffusing across the canvas. Let's go back and try it with 100 just for the heck of it, and I'll kind of wrap up this segment. So that looks reasonable. So the moral of the story on this segment are two things. First, when you see an attribute error, go back and make sure that the object you're trying to apply a method to have compatible types. In this example, we had to use a particle method on a particle object. The second thing is if you're unsure about the type of an object, just use the type function to actually have Python tell you what the type of an object is. If you do those two things, it'll help you avoid some of these errors. So let's finish up now and we'll talk about how we implemented the particle class, and we'll talk a little bit about how to apply some of this knowledge to Blackjack. Okay, let's take a look at our implementation of the particle class. So I've unfolded all the method definitions here. So it's very straightforward, simple code. We initialize, have two fields inside a particle. We have a position field and a color field, initialize such. Offset, well, this is exactly kind of like what you saw in Pong. We have basically a call to draw a circle here to draw the particle. And kind of the last interesting thing is this is our str method. So it goes through and takes the various fields, converts them to strings, and then just returns back a big long string with all the information about the object kind of smooshed together. Inside Blackjack, you actually have to work with three classes. You have to work with a hand class, a card class, and a deck class. You're given the card class. You have to implement hand and deck. One kind of thing that's going to help you build Blackjack is if you focus on getting the implementations of the various classes correct before you proceed on to the rest of the game. So this kind of leads you to kind of an interesting question, which is how do I know they're correct? Okay. Well, we're going to provide you in Blackjack testing templates that allow you to check to see if the implementations of the three classes are working correctly. So I've actually built a testing template for the particle class, and here's how we use it. We're going to take our implementation of the particle class. I'm going to copy it, and I'm going to go to the testing template. So here's the testing template. You've probably seen this if you've done the practice exercises. It says post your code for the particle class here, so I posted it. And notice what happens after that is I have a bunch of Python statements that create particles and print out kind of what the particle looks like, what its type is. I apply some of the methods to it. And then I have down here the expected output. So if our implementation of a particle class is working, we would expect whenever we run this code to actually see output that looks like this. So let's do that. And it says we get a particle position 2020, that's great, and a color red, that's great. The type of the particle is indefinitely indeed a particle. Those match. In fact, we can just go through and check that the output here matches the output over here. For reference, this is very similar to what you might see in some classes that are machine graded. This is basically a testing regime here, and it produces some output. And what happens is machine graded classes, typically the computer goes through and does this check to make sure these two things agree. For the games that we're building, it's not going to always be possible to kind of compare textual output to make sure your game works correctly. But here for Blackjack, we're going to provide you with three testing templates. One for a card, one for hands, one for a deck. Take your code, test it with these testing templates. Do not proceed with implementing Blackjack until you pass these testing templates. If you don't, you're going to have all kinds of errors when you start trying to use your incorrectly implemented methods for cards, hands, and decks. Hopefully this lecture gave you a few survival skills to make it through Blackjack. My best piece of advice for finishing Blackjack is follow the mini project development process. Use the testing templates that we provide for cards and hands and decks. Implement it so that you can play Blackjack using the console before you move on to doing Blackjack on the canvas. If you break it down into a step-by-step process, Blackjack is actually not too difficult to implement. Feel free, if you have questions, to send your code to the Code Clinic Interactive Python at online.rice.edu. We'll be glad to help.